Hello, this video is going to be about exponential functions. My attempt is going to make this so that I don't want to be too long-winded. I don't want to over-explain. I want to be very clear. Try pausing it. Try going back. If you have any other questions, you can leave them in the comments or let me know. So first thing I want to go over is the basic equation of an exponential function. Y equals a times b to the x. Now first and foremost, your y can also be f of x. Okay, it's the same thing. Y and f of x are the same thing. They just represent what number is coming out of the equation. Your x and y represent your point on your input, your output will represent your coordinates, x, y. Your b, your base, will represent your change. Circle this. This is your change. Change is it increasing or is it decreasing? Meaning, if it's increasing, the numbers are doubling, tripling, something like that. If it's decreasing, the numbers are being cut in half each time, or being cut by a third each time. Your constant here, this is your initial value. Okay, and this is where we kind of run into a little trouble with initial value. What that means is when x is 0, or basically when the graph, I guess you could say, starts. I'm going to explain that in the next slide. Okay, so here's your y equals a times b to the x equation. Again, we can write f of x equals a times b to the x. Okay, and that's just a fancy way. It's literally just a fancy way of saying it. It's an efficient way of saying it because it tells us what number went into the equation and out of the equation just simply without using y. I'll come back to that in a second. You're going to have two kinds of graphs. You're going to have a graph that's going to increase. Okay, we always read from left to right. Okay, read left to right. So if you're starting from the left here and you're going to go to the right and your values are increasing, you're increasing. Now if you, in another graph, if we had, okay, we started in the left and the numbers went down, well, that's decreasing. Fun fact, I don't know if it's fun for you, an exponential function will never reach 0. It'll just keep getting reduced, and it'll get as close as possible to 0 without even getting there. But as I said, the two kinds of graphs you're going to have are the increasing one and decreasing one. So our first question was always, well, is it getting bigger or getting smaller? Now, if I have a graph, I'm going to do this by example. If I have a graph that's like this, okay, here's my x-axis, here's my y-axis. Okay, and I'm going to do an example here. So we're going to use blue, and I'm going to just draw it increasing like this. We put a couple points in here too. Let's go green. So here's a point, here's a point, and here's a point. Okay, that's about it. So here's 0 on the x-axis, here's 1 on the x-axis. Oh, we missed that one. And here's 2 on the x-axis. Okay, and I'm going to say that on the y-axis, that's going to be 0.5. And here's 1. And then this is going to be 2. So, and then we'll have 4 up here. So what's happening is we got to figure out what the equation of this line is. So what I'm gonna do is I'm gonna write my base equation, y equals a times b to the x. Okay, it's call it a parent function, call it a base function. Okay, it's your blank clone of an exponential function. If you're ever writing an equation of any function, just figure out what the base is and plug values in that you know. So we said our a is our constant or our initial value. Initial value meaning what is the value of y when x is 0? Well, in this case, when x is 0, here's x is 0, y is 0.5. So we're going to say here that a equals 0.5. Okay. Now, one thing I forgot to do is I forgot to do the other x's, so I'm going to add those in right now. So, well, actually, no, we have the other x's. So we have this point right here. This is 1, comma 1. We have this x right here, or this point right here, which is 2, comma 2. So if you notice, we go from 0.5 on the y-axis to 1 to 2. Now in this case, we can easily say that it's doubling. So 0.5 doubled 1. 1 doubled is 2. So it's doubling each time. Well, doubling is a factor of 2, which means that our base, our change is 2. So b equals 2. So if I want to write my function here, my equation, this in black, we would have a is equal to 0.5 times 2 to the x. Sometimes you can put these in parentheses if you want. Okay, that's my equation. Maybe do one more. Maybe a little easier. Let's do one more. Erase all ink. Okay, so let's do one more. Okay, draw my graph. Let's go 1, 2, 3, 4, 5, 6. You just skip ahead if you want. 7, 8. And then let's go, I don't know. Let's go, tell you what, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Very simple graph. Okay, so what I want to do is I'm going to do this a little differently. So I want to start with the point 0, 1. Okay, I want to start with this point 0, 1. It's right here. Well, my y value is going to be 1. This is what do x and y. So the first time something's going to happen, I'm going to say, well, we're going to double. So y is going to double, it's going to be 2. Second time something happens, y is going to double, it'll be 4. Third time it happens, it's going to double again, it'll be 8. Fourth time it's going to double, it'll be 16. Okay, so in this case, your input is x, which is okay the initial iteration, which is 0, nothing's happened yet, which is where you're starting from, is 1. First time you do something, you double it, 1 becomes 2. Second time you do something, 2 becomes 4. Third time you do something, 4 becomes 8. 8 becomes 16 on the fourth iteration. So to graph this, we'll have 0, 1, 1, 2, 2, 1, 2, 3, 4, and 3, 1, 2, 3, 4, 5, 6, 7, 8. And you can see how things increase. Okay, so let me write my equation. Well, I'm going to say f of x, I want to do the fancy way, is equal to a times b to the x. A is my initial value. It crosses the crosses the y-axis, or x is 0. Should have labeled the graph, I apologize. So the initial value, it starts off x is 0. So x is 0, now your y value is 1. Your initial value, A, when x is 0, is 1. Now your change, as we said, is the numbers are doubling. Okay, they're multiplying by 2. So I'm going to say f of x is equal to f of x is equal to 1 times 2 to the x, or simply f of x is equal to 2 to the x. Now, I want to keep this little chart here and show you something as far as the f of x goes. So let's go yellow. I'm going to circle this one. Why am I circling this one? Well, what is the x value right there? It's 2. So I would say that your function of 2 is equal to 4. Now, why is that? Now, again, why is that? Well, go green here. If I were to put 2 into my equation, well, I would say, well, f of 2 is equal to 2 to the second. Basically, what I'm doing is I'm putting my 2 in for x, and for x. I'm replacing everything. But this also tells me, well, when the function value of for x is 2, when I put 2 in, I'm getting out f of 2 equals 4. So if they're asking you f of a number, it's asking for the y value. Let's look at these two right here as an example. Okay, hopefully you're not too bored right now, but I promise it'll work out. I'm going to write down my equation. F of x is equal to a times b to the x. Now the first one, okay, we obviously see an increase. So we're gonna have a number that's even spelled right, that's greater than 1, or so I should say greater than 0. Well, my initial value right there is when x is 0, y is 5. So my initial value is 5. Now I'm looking at my y numbers. Okay, it's 5, it's 15, it's 45. Well, again, this is one of those, you can do the math in your head. 5 times what is 15? 15 times what is 45? Exponential is always multiplying. Well, 5 times 3 is 15. 15 times 3 is 45. There is a consistency. So b is equal to 3. I would write my equation this way. F of x is equal to 5 times 3 to the x. Okay? Do not multiply and get 15x. No, 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 no. Just leave it as this. That's your equation. Next one. Again, from left to right, we see that it's decreasing. F of x is equal to a times b to the x. A is my initial value. And probably while you're thinking this, Why using A? Why using B? Well, we speak English. A lot of math was developed in other languages, so I think the A represented initial value translated in a different language, maybe like French or Spanish, something like that. So it's like why isn't using I if it's initial value? Well, there you go. Anyway, so it's decreasing initial value here. So when x is 0 is 20. Well, how is it changing? Again, the base. Well, it starts as 40, then it goes to 20, and then it goes to 5. Interesting. 40 to 20 to 5. But one thing you're missing, positive 1. Okay? So in this case, there'd be something going on right here. Well, I can do the math in my head. So 40, if you do it half of it from negative 1, which is here, negative 1, one iteration to 0 would be, okay, it's halved, 40 to 20. Well, then 20, for the next iteration would be halved again. So you'd have 110, and then it'd be halved again, which would be 5. So in this case, my b is 1/2. Numbers are halving. So my equation would now become f of x is equal to 20 times 1/2 to the x. Reading the question, here are two graphs of two exponential functions. For each, write an equation that defines the function. Well, I've written the equation. Find the value of the function when x is 5. Well, again, the way I would write this is, so f of 5, so my function of 5 is equal to, well, here's 0, 1, 2, 3, 4, 5. Well, as I can see in this one, it's not in the graph. However, I have the equation. So f of 5 is equal to 5 to the third to the fifth. So f of 5 is equal to 5, and now we're doing PEMDAS, times 3 to the fifth. Okay, well, let's get the calculator out. Okay, calculator. I'm literally doing this live. 3 to the fifth equals 243. And then I'm going to multiply that again by 5 for the next line. So f of 5 is equal to 1,215. I'm not going to show the f of 5 for the second decreasing function. I figure you can do it from here. I really hope this helps. I liked it. I wish you luck.